Welcome back to Aurora Tech Channel. Today, I will review a UV laser machine from ComMarker, their new flagship model, the Omni X. I've reviewed many diodes, CO2, IR fiber, and MOPA fiber lasers in the past, but this is the first time I've ever tested a UV laser. In short, a UV laser can mark on virtually any material, including transparent and mirror-like surfaces, something no other single laser type can do as effectively. This machine uses a galvanometer system. In simple terms, two mirrors that rapidly steer the laser beam instead of a gantry with wheels or rods moving the laser head. It can engrave at speeds up to 10,000 millimeters per second. By comparison, most diode or CO2 lasers max out at a few hundred millimeters per second. The laser spot size is also extremely small. According to the manufacturer, the UV spot is over 500 times smaller than a 1 millimeter CO2 spot. In my experience, I've never seen a CO2 laser spot that large. They're usually in the 0.1 to 0.2 millimeter range. So in reality, the UV spot is about 50 to 100 times smaller, which is still an enormous advantage. Diode lasers are a bit tighter, around 0.06 to 0.1 millimeters, and fiber lasers can get down to about 0.02 millimeters, but the UV laser's 0.002 millimeter spot is by far the smallest, allowing for ultra-high resolution engraving. The Omni X is fully enclosed and comes equipped with an LED light and circulation fans mounted at the top, along with a safety switch that detects whether the cover is open or closed. The footprint is approximately 14 by 26 inches. That includes the space for the cables at the back. The height is about 27 inches when it's enclosed, but you need an additional 12 inches of clearance to allow it to be fully opened, bringing the required vertical space to about 39 inches. With the stock 150 millimeter lens, the working area is 150 by 150 millimeters. An optional slide extension can expand this to 400 by 150 millimeters. The lenses, much like those on a professional camera, are interchangeable. For higher power density, the machine also includes a 70 millimeter lens, which is especially suitable for 3D engraving. Thanks to its tall design, the maximum workpiece height supported is up to 235 millimeters. The system supports autofocus using LiDAR. The manufacturer claims accuracy up to 0.001 millimeter. You can also manually focus using the buttons on the machine, the software, or by rotating the knob on top. In this video, I'll be testing various materials, including metals, wood, acrylic, plastics, and more. To demonstrate both 2D and 3D engraving, I'll also try out the rotary roller and the chuck. I would like to thank ComMarker for sending us this machine to review and for sponsoring today's video. Even though this is a beta test unit, I will still point out all the issues and cons I find. With that, let's get started. The machine came in a thick outer box for extra protection, so the inner box was still in good shape after the long journey of shipping. The top layers include screws, cables, accessories, and a 75 millimeter lens that we'll use later. The laser head, base, and arm are packed separately, so we'll need to assemble them. There's also an interesting yellow ping-pong paddle-shaped thing that helps make the preview visible on certain surfaces. We will try that later. At the very bottom is the enclosure, which is equipped with an LED light and circulation fans. Since there are only a few large parts, assembly should be straightforward. I'll keep everything in the box and take out the parts as needed. First, let's put the arm on the base, attach the mount, and then secure the laser head onto the mount. Flip the unit around and connect the cables from the base to the laser head. There's also a cable that needs to be connected to the arm for the Z-axis motor. Next, we'll set up the enclosure, snap the handles on both sides, then place it onto the base. I tape the cables to prevent the edges from rubbing against them. Tighten 4 screws on each side and the back. Then, connect all the cables from the enclosure to the back. They are all clearly labeled. We also need to connect the USB cable to the computer and plug in the power cord. There's also a foot pedal, but I won't be using it right now. Since this is a test unit, the exhaust duct wasn't included, so I 3D printed an adapter and hooked it up to my existing ducting setup. It's not pretty, but it works. Now let's look at the software and start our first job. ComMarker has finally moved away from the very old-school EasyCAD software to something with a modern interface, similar to Xtools software. By default, the machine comes with the 150 millimeter lens installed, so in device settings under Field, I'll make sure the parameters match. They do. If you want to switch to a different lens, like the 70 millimeter, you can load another profile. This beta software still has a few missing translations, but the parameters update correctly. Let's switch back to the 150mm profile for now. For our first engraving, I'll import a photo. Unlike diode or CO2 lasers where you mostly adjust power and speed, UV lasers also let you control frequency and pulse width, similar to a MOPA fiber laser. Let's spend a few seconds going over how that works. I made a simple scratch animation. It may not perfectly illustrate the physics, but it should give you a rough idea if you're new to fiber and UV lasers. For frequency, the higher it is, the lower the energy per pulse, but more pulses are delivered in the same amount of time. This is generally better for light surface engraving and for producing fine details like small text or images. For pulse width, with a shorter pulse width, the energy is more concentrated, producing cleaner and crisper marks. When the pulse width is set higher, each pulse lasts longer, transferring more heat into the material. This can create deeper engravings, but the edges may burn or blur, and fine detail can be lost. Things work a little differently with UV lasers. Unlike MOPA fiber lasers, which offer a wide adjustable range, UV lasers usually have a fixed or very narrow range. That's because UV systems are optimized for cold marking, low thermal input processing on plastics and glass. With UV, fine control depends more on adjusting frequency, power, and scanning speed. Alright, lesson over. Let's go back to our first test. I'll scale the design to about 90mm and use the preset parameters for wood since I'll be starting with plywood. Let's let the machine run autofocus to set the focal length. Make sure the red dot is on the material. The laser head will move up and down until it finds the optimal focus. Once it's in focus, the laser dot becomes sharp and as small as possible. If the dot looks large and blurry, that means it's out of focus. Autofocus is done, so let's draw a preview frame. On plywood, the preview is visible, but on some materials you won't be able to see it clearly. We'll test that later. The preview looks good. We can now start the job. The software shows the estimated time in seconds, which might test your math skills on longer jobs, but it is accurate. This run took exactly 252 seconds, or 4 minutes and 12 seconds. The result is stunning. This is my first UV laser test, and I didn't expect it to perform this well. Next, I'll try engraving on 6061 raw aluminum. I'll create a QR code using the software. You can choose barcode or QR code, then type whatever you want in the code. If you check display text, the text will show at the bottom of the code. By default, the software uses line mode, which just draws the outlines, but I'll also check fill mode to make it look more solid, similar to the example provided. Let's position it in the center and start our preview. On aluminum, you can't see the preview frame. You can use a piece of paper, but since paper isn't transparent, I'll try using the yellow ping pong tool. It's much clearer. However, since that tool is about 4.5mm thick, I'll just align the code to the top edge of the aluminum plate and see if I can position it accurately. There are settings for different metals, including aluminum, but I want to see what the general option is for, so I'll just try the general material setting. That job took about 18 seconds. I'll make another one, this time choosing aluminum to see if there's any difference. It took the same amount of time, and the results look basically the same. Looking into the material library, I noticed that the general parameters are actually identical to those for all the different metals, including aluminum, stainless steel, mirrored stainless, copper, and even other metals and plastics. The only exception is transparent acrylic, which has slightly slower settings. Everything else is the same. Let's go back to the QR codes and check if they work. Yes, they scan perfectly. And by the way, don't forget to check out my website for my price tracker on popular machines. Next, I'll engrave the same QR code on a piece of mild steel. Since all metals share the same parameters, I can simply start the job again. This took about 18.5 seconds. the result looks very different compared to aluminum. The marking on mild steel is black, with a very sharp contrast. The text is also extremely clean, even though the letters are only about 1 millimeter wide. Now I'll try some clear acrylic. While UV and CO2 lasers can mark clear acrylic directly, diode and fiber lasers can't without a surface coating. I put a piece of paper underneath for easier alignment, and I was also curious to see if the UV laser would leave a mark on the paper as well. This job took 314 seconds, or about 5 minutes and 14 seconds. The laser marked the acrylic cleanly, though there were some very light marks on the paper underneath. The engraving shows different shades of gray, and when you flip the acrylic, you can see the design clearly from the back as well. The result basically matches the image in the software. Next, I'll test some 3D printed parts. I'll mark text onto this PLA box using the plastic or general material settings. It's pretty fast, and the cold marking process works really well on 3D printed parts. You can still see the surface texture from the PEI sheet. It doesn't heat up and melt the plastic like other lasers might. The machine even came with some dried leaves, so I'll try engraving a photo on one of them. There's no leaf setting in the material library, so I'll select paper, which interestingly has the exact same settings as metal and general material. The job finished in about 3 minutes, a little faster than engraving wood. The leaf shows a semi-transparent effect where it was engraved. It's pretty cool, though I personally prefer how it looks on wood. So far, I've been using the 150mm lens. Let's remove it. You can see it uses a screw-mount lens system with a 2-mirror galvanometer inside. The screw mount is similar to what you'd see on vintage cameras. The machine also includes a 70mm lens, which provides a more concentrated beam, so I'll install that one and try some 3D engraving. I'll use the 3D glass mode and import an STL file. This is just a regular STL file for 3D printing. You may recognize Vegeta, since he shows up a lot in my 3D printer review videos. The acrylic block I'm using measures 48 by 48 by 100mm, so I'll scale the model down to about 75%, which brings the total height to around 86mm. That seems to fit well, and there aren't many other settings to adjust. For autofocus, you need to align the red dot to the base. In my case, I placed a piece of wood under the block and let it focus there, which matches the bottom surface of the acrylic. For the preview frame, it's hard to see on clear materials, so I'll use the yellow ping pong tool again and try to position the engraving as close to center as possible. During the engraving, the laser penetrates all the way through, but by default it leaves an offset of a few millimeters from the bottom. At first I didn't realize this, but after confirming with ComMarker, that's how it's designed to work. To fix it, I'd need to either lower the laser head a few millimeters or raise the acrylic with a piece of wood underneath. For now, I'll just let it run and see how it turns out. Here's a 20 times time lapse. Of course, in real time it doesn't engrave that fast. Here's the actual speed. A little faster than a 3D printer, but still much slower compared to 2D engraving. Just like a 3D printer, it engraves layer by layer and slowly works its way from the bottom to the top. There's no estimated time shown, but the software displayed a runtime of about 53 minutes, and that was almost exact. The final time was 53 minutes and 20 seconds. Because of the Z offset, the model's first layer was raised a few millimeters, which cut off the top of Vegeta's hair slightly. Besides that, the engraving came out beautifully, with crisp and detailed results. Finally, I'll test the rotary rollers. The machine includes both a roller and a chuck, but I'll start with the roller. Since I don't have a stainless steel mug, I'll use one from the Eufy Make UV printer, which has a vinyl-coated surface. I experimented with different settings to dial in the best balance between speed and power. Some trials had too much power, while others were too light. After some testing, I found the best results came with 5,000 millimeters per second speed, the maximum for the roller, 150 kilohertz frequency, and just 1 microsecond pulse width. Using those parameters, I engraved a logo on the opposite side of the mug. The job only took 3 minutes, and the result looks great. Of course, I don't mind showing the behind-the-scenes process with all the trials and errors it took to get there. I'll also try the chuck, which is meant for small objects like rings. As expected, the preview frame doesn't show up clearly on a ring, and even the yellow ping pong tool wasn't much help here. So the best I could do was keep the UV laser dot as close to center as possible and hope for the best. The job finished in about 20 seconds, and surprisingly, the alignment wasn't bad at all. I'd say it's still acceptable. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The build is solid. The whole machine with the enclosure weighs over 120 pounds, which makes it really stable. Assembly is simple with just a few large parts to put together. 2. The autofocus system is accurate. It uses LiDAR, which makes it extremely precise. The manufacturer claims accuracy down to 0.001 millimeter. I can't verify that exact number, but from all my tests, it's been spot on. 3. The speed is extremely fast. On a diode laser, engraving a photo of similar size usually takes around 40 minutes because the head has to move back and forth on rails. With the galvanometer system on this UV laser, it can reach speeds up to 10,000 millimeters per second. That same photo can be engraved in about 4 minutes. 4. The engraving quality is stunning. The laser spot is only 0.0019 millimeters. That means photo engravings look sharp, clean, and highly detailed. 5. It works on almost anything. UV lasers are especially good for plastics and 3D printed parts, since the cold marking process doesn't melt or warp them like other lasers can. And it's not limited to flat surfaces. This machine can also engrave transparent objects and even create 3D engravings inside acrylic or crystal blocks. 6. You also get flexibility with lenses. Swap to a larger lens for a bigger working area, or use a smaller, more focused lens for deeper or 3D engraving. It's like using a professional camera with interchangeable lenses, while lower-end lasers with a fixed lens are more like point-and-shoot cameras. Now for the cons. 1. The fans are loud, the enclosure fans run constantly, and the noise level can hit 70 decibels, a bit too loud for most offices, homes, or even workshops. ComMarker told me they will allow the firmware to control the fans, so they only turn on when the internal temperature is above 36 degrees Celsius. But in my opinion, that's not enough. A better solution would be to use PWM fans, so the speed ramps up only when temperatures are high, instead of blasting at full speed all the time. 2. The LED lighting isn't effective. It's mounted at the top, but the large laser head blocks most of the illumination. The light really needs to be relocated to the side, or anywhere other than the top. 3. The preview can be tricky. The frame preview is accurate and great for alignment, but with UV lasers, you often can't see the dot at all on certain materials. That's where the yellow ping pong paddle tool helps. It works fine with flat and large objects, but when I tried the rotary attachment to engrave a ring, it became guesswork. And honestly, if that were a customer's diamond engagement ring instead of a cheap steel ring, I guess you would be nervous about hitting the start button. 4. Smoke management needs improvement. UV lasers don't make much smoke on metal or plastic, but wood still does. The circulation fans pull it upward, and with the exhaust port unfiltered, that smoke ends up in your room even with a duct fan. ComMarker says a new smoke purifier is coming that connects to the back of the machine and should handle smoke and fine particles much better. We'll see how it works in the final version. In conclusion, the Omni X UV laser opens up many new possibilities for a laser engraving business. Since anyone can spend a few $100s on a diode laser, basic engraving on wood or other common materials is already crowded with competition, which drives prices down. But being able to do 3D engraving inside a crystal really makes your product stand out, and more importantly, it gives you the chance for higher margins. Overall, this is a solidly built machine. The UV laser performs very well, with only a few minor issues in the enclosure design on this early test unit, but those issues are not hard to fix. The software is fully functional and a big step up from the old EasyCAD. It's not as polished as Xtool's software, though that extra polish is reflected in Xtool's premium price. Still, this new interface is a good start. I've already received 2 updates during my testing process, so I believe ComMarker will keep improving it. If you're interested in the Omni X UV laser, I put a link in the video description. And don't forget to also check out my website, auroratechchannel.com, where I track prices for popular 3D printers, laser engravers, and CNC machines to help you find the best deals. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.